Okay, now that we understand what a number is when it's written in scientific notation, let's actually do the conversion. Let's take a number that you're used to seeing in standard form and converting it into scientific notation. So the number I want to use is that 93 million miles, okay, the distance from the Earth to the Sun. And we know that that is a very large number that has a lot of placeholder zeros. So to write a number in scientific notation, the first thing you want to do is locate the decimal point in the original number. So in the number 93 million, where is your decimal point? Well, I know it's not shown, but we all know with any whole number, the decimal point is at the end. So that decimal point would be located behind the last zero. Okay? Now what we want to do to write a number in scientific notation is we want to move that decimal point to create a number bigger than 1, less than 10. Okay? So we're going to physically take that decimal point and move it to a different location in that number. We're going to place it between two digits that makes a number between 1 and 10. And if you all agree, we could take that decimal point and put it right in between 9 and 3. If we put that decimal point in between 9 and 3, we would have the number 9 and 3/10. And that is a number between 1 and 10. So that's the first thing we do. Now, with scientific notation, now that we have our decimal value, then we're going to write times 10. And remember, why do we write times 10? Because our whole number system is based on powers of 10. Every single one of your place values is a power of 10. The ones place is 10 to the 0. The tens place is 10 to the first. The hundreds place is 10 squared. The thousands place is 10 cubed, etc. So anytime you write a number in scientific notation, once you get your decimal value, then you write times 10, and now we need an exponent. You get the exponent from counting positions. You are going to count where the decimal point is now, where you placed it. How many times do you have to move it to get back to where it originally was? So remember, we had the number 93 million. In 93 million, the decimal point was at the end behind that last zero. But now you've moved that decimal point to be between the 9 and the 3. So now it's here. So now we're going to physically count how many times it takes us to move it back to the original. Because we're going to be moving to the right, our exponent's going to be positive. If we were going to be moving to the left, our exponent would be negative. So now just take your finger, put your finger where the decimal point is now between the 9 and the 3, and count your movements. 1, 2, 3, 4, 5, 6, 7. And that's where we get the exponent 7. So our number 93 million, written in scientific notation, would be 9 and 3/10 times 10 to the 7th power. Anytime you write a number in scientific notation, you are not writing the zero placeholders. That's the whole point of scientific notation. Okay, let's go to the whiteboard and try a couple.